Good morning, sir. My name is Chakri. I am from mechanical department in second year. Today my topic is single side crank chain. Introduction to single strider crank chain. A single strider crank chain is a mechanism used to convert linear motion into rotatory motion. It consists of a crank connecting rod and a single slider that work together to create this transformation. Understanding this mechanism is essential for various applications in engineering and machinery. Single-sided crank mechanism, bull engine, oscillating cylinder engine, rotatory internal combustion engine, quick return motion mechanism. Component of the mechanism. The main component include the crank slider and connecting rod. The crank is typically a rotating disc that converts rotational motion into linear motion. The slider moves along a predefined path connecting to the crank and the connecting rod. Working principle. The crank rotates around a fixed axis, causing the slider to move linearly. As the crank rotates, the connecting rod transmits motion for the crank to the slider. This continuous motion allows the mechanism to perform work efficiently. Application in machinery. Single-sided crankchain are commonly used in internal combustion engines. They are also found in various types of pumps and compressor. This mechanism plays a crucial role in converting energy in many industrial applications. Observe in this figure slide slider crank mechanism. Types of slider crank chains. There are different configuration of single slider crank chain, including the standard and modified types. Each configuration serves specific purpose in mechanical design. Understanding these types helps in selecting the right mechanism for a given application. Single sided crank mechanism, bull engine, oscillating cylinder engine, rotatory internal combustion engine, quick return motion mechanism. Advantages of single sided crankchain. One major advantage is the simplicity and easy of design. They also provide a smooth conversion of motion, reducing wear and tear of components. Additionally, they can be easily scaled for different power requirements. Limitations of the mechanism. One limitation is that they can have issues with friction which may affect efficiently. They also have limited stroke length which can constrain their application. Finally, the mechanisms may require maintenance to ensure continued performance. Force acting on the mechanism. Various forces act on single slider crankchain during operation. These forces include tension, compression, and inertia affecting the overall performance. Understanding these forces is important for effective mechanical design. Kinematic analysis. Kinematic analysis involves studying the motion of the mechanism without considering force. It helps in understanding the relationship between the crank angle and the slider position. This analysis is essential for optimizing the mechanism's performance. Observe in this figure. Dynamic analysis. Dynamic analysis consider the force and torque acting on a mechanism during operation. It helps to predict the performance under various loading conditions. This analysis is crucial for ensuring reliability and surface safety is, in applications. Design consideration. When designing a single slider crankchain, material selection is crucial for durability. The geometry of the component must have optimized for effective motion transfer. Additionally, clearance and tolerance should be careful considering to prevent malfunction. Manufacturing process. Various manufacturing processes can be used to create single-threaded crankchain. Common methods include machining, forging, and casting depending on the application equipment. Choosing the right process affects the quality and the cost of the final product. We are observing this figure. Manufacturing process types: processing operation, assembling operation. Maintenance practices. Regular maintenance is essential to ensure the longevity of the mechanism. Lubricants helps reduce friction and wear between moving parts. Additionally, periodic inspection can identify potential issues before they lead to failure. Future trends in design. Advantage in material and manufacturing technology are shaping the future of single slider crankchain. Innovations such as additive manufacturing may allow for a more complex design and lighter component. The integration of sensor and smart technology can enhance performance monitoring. Case study. Several case studies illustrate the successful application of single-threaded crankchain. An example includes their use in automotive engine where efficiency is paramount. Another case study highlights their role in industrial machinery, emphasizing reliability and performance. Conclusion. The single-threaded crankchain is a vital mechanism in modern engineering. Its ability to convert motion efficiently makes it indispensable in various fields. Continued research and development will enhance its application and performance in the future. Thank you for this given opportunity.